Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. This is a fascinating episode. I got the opportunity to interview Lonne Jaffe, Managing Director of Insight Partners and prior CEO of Precisely. Lonne may know more about the history of the data ecosystem than anyone I've ever spoken to. It's not totally clear how he knows all of this, as we started our careers at roughly similar times, but the depth he can speak to things that occurred back in the 1970s is impressive. I used the hour we spent together to suck as much knowledge out of his brain as I could. My goal was to start at the beginning and just march through 50 years of history as efficiently as we could. We start with the mainframe and why sorting was a big deal in a world of hierarchical databases. We track through the advent of the relational database, early ETL, data warehouse appliances, Hadoop, and now the cloud. We talk about why data prep and data management have historically been different categories, and why it's historically been challenging to overcome switching costs in ETL. Finally, Lonne shares his view as an investor on where the ecosystem is today and what problems remain to be solved. As you might expect, he and I are very aligned. The future of the AI and standards era is bright. I think you'll enjoy this conversation, and I know I learned a ton. Without further ado, let's get into it. Lonne Jaffe, welcome to the Analytics Engineering Podcast.
Great to see you, Tristan. Thanks for having me.
This is one of those fun excuses that podcast hosts get to catch up with folks that they haven't been able to chat with in a little while as an invite on a podcast episode. So it's been a couple of years since we've caught up.
Yeah, no, it's a lot has happened. Looking forward to talking about it.
You have had a long career in tech. I thought maybe we'd just start out by giving us the 30,000-foot view of what you've been up to over the last couple of decades.
Sure. So I have been at Insight Partners for about 8 years, actually 8 years exactly as of yesterday.
Oh.
I joined after being CEO of an Insight portfolio company, though. So I was kind of in orbit for a few years before that. The company was called SyncSort. It's now called Precisely. It was an older software company founded in 1968 that I did not found, but I joined in the 2013-ish timeframe. And at Insight, I've been working on some of our deeper tech investments. So that ends up being things like some AI infrastructure companies like Run AI and Deci AI, both of which got acquired by NVIDIA last year. I've done some application layer investments, but they tend to be kind of deeper tech oriented. So like Featurespace, which was issuing bank fraud detection. It felt a little bit like a financial services application, but the people who showed up every day at the engineering team were kind of deep tech machine learning folks. They got acquired by Visa last year. I've also worked on a number of data infrastructure investments, so things like Single Store, which is a fast analytical and operational database in the cloud. And then before I joined...
I love this. We're going backwards in time instead of forwards in time.
Yeah. I was at IBM for about 13 years. IBM is a very old technology company based in suburban New York. At IBM, I had a lot of different kinds of jobs and was relocated a bunch of times, including once internationally. For a lot of the time I was at IBM, I was in the application and integration middleware division. So this included things like Webster Application Server, CICS, which was one of the original, very foundational mainframe transaction platforms, TPF. IBM, by the way, had a lot of other kind of mainframe databases that were very interesting. If you added them up, it was a very large amount of annual revenue that was extremely high margin. And yeah, that's a quick flyby of my career.
I don't know a ton about Precisely, but I was doing a little bit of research, and when you ran it, it was called SyncSort. Is that right?
That's right. Exactly.
Okay. And my understanding is that inorganic growth played a major role in both what you did at IBM and at SyncSort. Is that fair to say? Like there were a bunch of roll-ups involved there?
Yeah. I mean, SyncSort has a very long history, right? So it was founded in 1968. It was one of the first software companies that was created, right? Back in the late 60s, the IBM 360 mainframe and the software layer were pretty tightly coupled. There was a antitrust activity that at one point helped to catalyze the decoupling of the software layer from the mainframe. And there were a few software companies then, and more emerged soon after that. But SyncSort's original sort of vision at the time was, we're going to have a better sorting system. And sorting was a huge portion of what you would do in computing back then.
And when you say sorting, you literally mean like an order by clause, right?
Yeah, it ended up being more complex fairly quickly. So people, called it sorting, but it was doing, not just large scale telecom billing sorting, but you started to see early things emerge like merging and joins and aggregations and things like that. But a lot of the data back then was hierarchical, right? So it was stored in things like IMS. And so you think about it like it's basically like trees, right? Parents and children. And in order to do anything with the data, you had to traverse the trees and basically flatten the hierarchical data into a file.
So you can imagine the algorithms used to do any of this stuff are like totally different than the way that you would do it in a relational context. Is that fair?
For sure. And you were, I'd say, even more significantly than the hierarchical versus relational, was that you were working. It's a little hard to wrap your mind around like how much more disk space or tape drive space and memory and things like that you were constrained around. Like all of NASA had less computing power than probably my Apple Watch does today, right? And so you were so the efficiency of the algorithms were very important, but they're still very important. Like if you look at what when Spark first emerged as a thing out of the whole big data Hadoop universe, what was the first thing that they did to show off how good Spark was? Is they had it compete in the gray sort benchmark, right? So sorting was still, if you look at the internals of even something like MapReduce, there was the map sort and the reduce merge, right? There's an enormous amount of sorting that's going on, and even though you have a lot more compute to work with and it's easier in a relational context, performance, in sorting and related things like merging and joins and aggregation still is very, very important.
Okay, that was a fascinating answer to a question. I didn't realize we were going to get into history so quickly.
I did do a lot of M&A. So I always viewed M&A as an important tool in the innovation toolkit. So you can build things, and we did build a number of things while I was at SyncSort. But there were just a lot of really interesting assets out there that we could give lift to and integrate with the rest of our portfolio. So like the first company I acquired while we were there was this company called Circle Computing Group that had what was called a transparency solution. So this was something where, so on the mainframe, you had a lot of data that was still stored in IMS in a hierarchical format and was being accessed. So IMS has two pieces to it. There's IMS, the database, and then there's IMS TM, which is basically the application server, where you would write the COBOL code to write the application itself. And what the transparency solution would do is it would trick the application into still thinking that it was accessing the data in IMSDB, the database, but actually you would intercept the call and you would send it to where the data was now, which was in often DB2Z, which is a relational database that is still pretty popular in the mainframe. And so you could move your data into DB2Z without having to rewrite the application. And being in a relational format in DB2Z was useful for a bunch of different reasons. One, the database was getting better more quickly, but also you could access it by all the other kinds of tools that needed data to be in a relational setting. So you could see how like in our strategy was very much at the time this kind of big iron to modern data stack systems value proposition, which is there is a lot of data that's locked up in these systems that that are working fine and people are not moving it. I'm sure we'll get to the topic of the things that GenAI might do in the ETL world, but the one thing it could do is erode switching costs, which is I think an interesting topic. But if you sort of liberate some of the data on the mainframe, now your like modern analytical system, your dashboarding products, your analytic systems, things like that, they're not toys because they can access your actual data, which is important.
Just as an aside, many of your titles in these roles were like VP of strategy and things like this. You very business-oriented roles, but you talk like somebody that has an undergrad degree in computer science or something similar. Like, do you have a technical background?
I did a couple of years of programming at Stuyvesant High School. I worked.
Shout out to your high school CS teacher.
Yeah. In college, I worked summer after freshman year at Columbia Records doing web design stuff. It was mostly a Perl system. And then interned at Microsoft summer after sophomore year and junior year. But no, my undergrad was not in computer science. And then I did a master's in the fourth year in history of science. I did focus on the use of encryption technology in scientific publishing from old days to Galileo's era to the present, which is long topic.
I love that. That's a different podcast, but we'll do that someday. Since you mentioned your undergrad, this is my favorite fun fact that I've ever found while doing research for a show. You participated in a juggling society. Is that correct?
Yeah, it was interesting. Like I got to Harvard thinking that I was an extremely good juggler. And it turns out I was like probably the worst juggler at the Harvard juggling.
Harvard has a way of putting you in your place. You're like, I thought I was good at math. I thought I was good at juggling. How many things can you keep? How many balls can you keep in there at once?
I can juggle 5.
I can only do 3. I'm a rank amateur.
3 to 4 is hard, but 4 to 5 is a big jump. And I can't say that I'm like completely reliable. Like I can't do it forever. But yeah, it's very, juggling is an interesting metaphor for like keeping a lot of things in the air, which we all have to do.
Totally. It's one of my favorite things to, I don't have a lot of like random skills. Most of my time is just like spent on, I don't know, work and being a dad. But every once in a while, somebody will ask me like, tell me a random fact, and I'll grab 3 things and juggle them. And they're just like, you're blown away every time. Do you ever use this as a party trick?
It's
oh, come on.
Not very often, but occasionally, like we'll have, you'll have like a talent show or something, right? And it's useful for that.
Yeah. Okay. I am glad that we went into history right off the bat, because the reason I wanted to have you on is because I have to imagine partially because of the IBM experience, but also because of the SyncSort experience, which SyncSort had this like deep history of backstory. I have in the past had some of the most interesting conversations with you of anyone I know about kind of the trends and forces in the data industry. And so I wanted to talk with you a little bit about kind of the backstory. So, certainly I think most listeners will be very familiar with the rise of the cloud data platform, that we're living in that now, or maybe we're at the kind of mature stages of that. And maybe that's even being kind of disrupted by AI and standards like Iceberg and whatever. But you go back before that, and you've got the Hadoop big data, the era. You go back before that, and you're probably at like Teradata, Vertica. But I think that many practitioners today, including me, I have very little insight into data. The data ecosystem's been around for freaking ever. So I'm curious, like, what these proto trends were that still impact our lives today, like Informatica, MicroStrategy, a bunch of companies that are like still very much alive and kicking, were born, I think, in the 90s. So I'm just interested to get your take on how do we extend this view of history let's call it 2010?
Yeah, it goes way back, right? You had in 1971 or 2, you had there was a IBM CICS added the journal shipping capability. So this was allowing regional banks to replicate transaction logs every night. And this was like the first change data capture product.
Oh my gosh. Replicate transaction logs. It's a question of like milliseconds or seconds or nope, overnight.
Yeah, everything was overnight. But, it was, you saw some things like, I think it was in the mid 70s, there was this thing called JCL, Job Control Language. And, there was an insurance company that had a single missing JCL comma that halted like every overnight batch. And it was, like a major data pipeline problem. And, you had the sorting systems, like IBM eventually had their block set algorithm in DF sort and SyncSort, and those were kind of proto ETL products in a way. Nobody was calling it that. I think the first time people used the concept of extract, transform, load was in 74. It was that IBM Systems Journal article. And then I guess you had Michael Stonebreaker's Ingress project in 79. That was where you started to get things like copy commands that could bulk load flat files into relational tables. So I think that was a big inspiration for some of the early ETL startup founders. right? And then DB2.
But that was in 79. When you say like early ETL startup founders, like when was the first like pure play ETL tool?
I think the first one, like that you would say was like a true ETL startup, was probably Prism Solutions in '88. So they had this product that was called Warehouse Manager, I believe. And so they had like a GUI, like a graphical interface on Unix workstations, and it was expensive. I think they charged something like $1 million a license. And this showed people that, and this, in 1988 dollars, right? And so I think this showed people that you could do data integration as like a standalone market, and it could be pretty interesting. But there were things going on even in the early 80s, like IBM had DB2 on MVS, and so you had these teams that would write generator programs that parsed COBOL copybooks, and like they would shoot out load utility cards, and so you had like mass schema moves and a lot of the sort of like subcomponents that you would eventually see in ETL tools. And I mean, I just like one big macro point is there's a lot of stuff that people don't call ETL that when you really squint at it is kind of like ETL, right? Like, you have these systems in industrial automation environments where you're like pulling data off devices and you're moving it through SCADA systems and putting it into these things called data historians to predict when machines are going to fail.
Mm-hmm.
And like nobody calls that ETL, but you're like extracting data from places and you're transforming it and you're loading it into these systems that look a little bit like databases or data warehouses, and you're doing analytics on them. Or, I mean, even today you have companies like, my wife works at Plaid, which is like a fintech company, and she co-chairs a technical steering committee for the Financial Data Exchange, which is the open standards body that defines how banks can share consumer banking data with fintechs and other authorized third parties. And like, if you look at what they do, it actually looks a little bit like ETL, right? They're extracting structured data from banks, and they have schemas, and they're doing metadata management, and they're loading that data into other systems. So I think there's like always been a lot of that. I mean, Teradata, when they showed up, I think there was like, and we came across a lot of Teradata customers, because you would go to these, these Hadoop conferences back in the Hadoop era, and it's like half the companies that were exhibiting there were doing some form of Teradata offload, right?
Like the use case for Hadoop often was just like reduce my Teradata costs.
Right. You would put it in front of the simplest architecture there was you would put it between your source systems and Teradata. And you would do a lot of the pre-processing in Hadoop at like orders of magnitude lower cost. And then you would load Teradata, because the other way you were doing it was you would do the push down ELT in Teradata. And it wasn't just that it was much more expensive, but it would use up limited Teradata capacity. So there was contention with the actual thing that Teradata was good at, which was the analytics. And that's also still true today, right? You look at
right, like the lines have started to blur a little bit, but when you're talking about that, it's not that dissimilar to the way that maybe circa 2019 customers would think about Databricks and Snowflake. Databricks
totally,
is upstream of Snowflake and blah blah blah.
Yeah, and a huge portion of Databricks is really doing some form of pre-processing and ETL, just like you saw with Hadoop before Spark emerged. But I guess like the real ETL market really kicked into gear with DataStage and Informatica, which was the early 90s, as you said. So DataStage was a VMark, which then became Essential, which got acquired by IBM. Informatica was around 1993.
Yeah, I was going to say, I don't know DataStage without the word IBM in front of it. So that makes sense.
To your question earlier about inorganic growth, a lot of these things, even that people perceive as organic products because they were within the companies for such a long period of time, actually started out as acquisitions. But yeah, you started to see the first like replace hand coding COBOL queries and things like that with drag and drop design that compiled into something that looked like a optimized execution plan. That had like intermediate representation layers that were sophisticated and different from the actual thing that happened in the boxes and lines designer tool, and different from the actual plan that got implemented in the physical hardware.
Why did both of these companies start in the early 90s? Was it like the rise of database technology or the internet, or like what unlock made that happen for two companies at once?
Yeah, I mean, it's probably worth mentioning another company that people may not be as familiar with anymore, but was pretty important at the time, called Ab Initio.
Oh yeah,
which
yeah.
was
We still run into it's a lot of like large banks, and they're just like, we still have this big ab initio footprint. I'm like, okay.
their angle was an extremely high performance ETL product that was highly parallelized. And before the pure play ETL products, you did do a lot of data transformation in databases of various kinds. And I think part of what you were seeing is an early sort of Jevons paradox dynamic where you had hard drive prices went from something like $500,000 a gigabyte in 1982 to what is it, like 3 or 4 cents a gigabyte today, something like that, right? So call it 6 orders of magnitude price declines, but you saw a tremendous amount of expansion of usage. So the market is much bigger. Separate question about like how much profit pool emerged in that market, which is different from the market size itself. But you saw a number of those things happening. So network I/O, storage, which was very important, to store all the intermediate representations as you were doing these transformations, memory, compute, all of them were dropping in price, and so people started to be able to do things like parallelize the ETL task and do more sophisticated types of joins and merges and aggregations. It was very high elasticity of demand. So as you like made it more powerful, like better algorithms and more compute and more storage and all of that, as you dropped the cost of those things, it was more than eaten up by people's appetites to do more interesting and more sophisticated analytics. And it was kind of like an ASIC in a way, like a special purpose system that you could offload the ETL work to something that wasn't happening in the database or the warehouse. And that became a really popular pattern because it freed up, your on-prem database or MPP data warehouse capacity to do more interesting things like the interactive SQL queries or sporting or whatever you were doing with it.
Is it fair to say that the space that I believe Gartner would identify today as data management started off with extract, transform, and load? Like that was the seed, the core use case? Because right now, data management has grown well beyond what you would, just kind of the Informatica Power Center.
There became a like classic ETL vendor bundle, right? Informatica did it, and then you saw others like Talend and a few others sort of mimic the same suite of products. But it was basically, there was usually an ETL product. There was like a change data capture product. You would also see them bundle in this thing that people would sometimes call app-to-app integration. This started out, there's this whole other world.
This is like booming.
Yeah, so you had these other products. At IBM we had WebSphere Message Queue, WebSphere MQ, and Message Broker. You had Software AG had a bunch of products in this category. Web Methods, and these were, you pulled data from an application via the application API, and you usually moved it somewhat more real time, and then you put it into often another application or maybe a data warehouse. And that world stayed really separate from the ETL world for much longer than I would have thought it would. Because you're kind of, these days it's been blurring a little bit, but like at the time it was like, no, there's a whole separate type of tooling that you use for pulling data from databases and moving it into data warehouses than the stuff you would pull from, say, Salesforce and move it into Workday. But the ETL vendors often had that functionality as part of their bundle. And then you eventually started getting like catalogs and what used to be called metadata repositories and are now called data catalogs, and a few other things like that. And that, when I was at SyncSort at the time, I think the ETL market was about, call it 3 billion or so a year. And to put that in perspective, the database market was probably around 30 billion or something at the time. So call it about a tenth, if you think of it as like an attach rate to what was going on in the database space.
There's this interesting dynamic that starts to occur. I think, well, maybe on some level it's occurred since, the 80s when you were talking about this market kind of starting, where spreadsheets and ETL kind of started around the same time. And so you've got your like IT people that are doing data management and your business people that are doing spreadsheets. But this dichotomy kind of matures a little bit, I think, in around the 2000 era, but you can tell me if that date's wrong, where data prep becomes a category. So it's interesting. There's this like persistent difference in tool set, you would think that like there's a job to be done. That job to be done is like moving data, reshaping it, whatever. And you would hope that those tools could like service different personas. But in fact, there's like completely different market segments and tooling for these different personas. Is that fair?
Yeah, it was definitely persona driven, right? So you would get these new capability unlocks that would make something like either easier to use, or you would develop the ability for people to do stuff without having to go through central IT within large enterprises, which was often a bottleneck. So yeah, you had, I'd say like in the early 2000s, a couple of things happened. The data warehouses started to hit the MPP data warehouses like Teradata and Netezza and Greenplum and Vertica. They started to hit size limits.
Like you couldn't add more nodes, or it became too expensive, or what?
It was very expensive. You were running into capacity constraints, and people like just sort of talking through the bottlenecks, and like people were really experiencing that as a bottleneck. And the ELT pattern of pushing transforms into the warehouse, which is what a lot of the boxes and lines ETL tools were doing. Like if you looked at, a lot of the Teradata capacity, it was like doing workloads that were, say, pushed down from Informatica.
Oracle Warehouse Builder pushed down in 2003.
Right. So you actually saw then, this is when SyncSort launched its DMX product, which was a very fast ETL product. And, then DMXH, which ran on Hadoop. And you started to see these open source ETL alternatives show up, like Talend, but also like some of these self-service systems like Pentaho, Kettle. And
so they all showed up in that era specifically because that's when the scalability of the columnar, database appliance was kind of running out of steam.
Right. So you were running into this issue where like limited human bandwidth on the data teams and limited capacity on the centralized data warehouses, but like people still wanted to do the stuff. They weren't like, oh, okay, I guess I'm just not going to like try to figure out churn prediction on my customers, or I'm not going to do marketing mix management, or
right.
Like,
so they're like, who has some compute capacity? Like I do on my laptop.
Totally. Yeah, that's exactly what happens. And there were a lot of false start things too. Like you saw this whole world of what people called data federation. Sometimes they called it data virtualization, which was a little confusing because the word virtualization was already taken. Like composite software from Cisco and Denodo and a few others. That market never got huge, right? It was this idea that you could keep data on the source systems and just put like a catalog or cache or something in a centralized location, and then send all the queries to the source systems to do the work, and then bring like aggregated or pre-processed data into centralized location, zero copy analytics. I don't know if you've ever seen like big deployments of that, but in practice, people still bring data to centralized locations. That's the main way that people do stuff. And then there was clickstream data, which started to show up around then because you had the internet became a thing, and so you got all these web clickstreams and unstructured logs, and so that was starting to drive the sort of whole big data phenomenon. The release of HDFS and MapReduce, and then eventually Spark. A lot of that was being used to kind of like offload the pre-processing capacity. And yeah, you had these self-service analytics products, and you had a similar thing happening on the dashboarding side, right? You saw the emergence of Tableau, to mirror the big BI tools that ran against the larger the larger data warehouses.
Earlier in this conversation, you were talking about, it was the 1970s, and you were talking about how essentially the way I translated it was there were abstraction layers developed so that you didn't actually have to rewrite an entire application, and you could essentially point the application logic to a new data layer. So it kind of speaks to just how sticky some of this code can be, because the cost of replatforming is so unbelievably high. In my travels, I certainly run into lots and lots of install base that still exists from tools like that we've mentioned that were built 30 years ago. What makes this stuff sticky? Is it just like it's expensive to move off of it? And if that's just the answer, then like, are we still going to see people, like, are the revenue streams of these companies still going to be flat in 50 years? Like, what the hell is, like, are we all going to be running all this stuff like when we're all in the grave?
This is a very interesting topic. Take this with a little bit of a grain of salt, because I haven't seen a lot of evidence of this yet. But if you just think about like, there's a huge number of products in this category, but also I would say like the database world has a lot of products like this too, where I'll exaggerate for the purposes of this discussion, just to sort of make the point. It's like you might have a situation where you ask 1,000 customers, do you love this product? And 0% of them will say yes. All of them would love to move off of the thing that they're on to something that already exists, right? You don't need to wait for something to get built that's new. There's already a better, faster growing, more modern thing that they could move to, but they don't, right? And the vendor is able to raise prices, cut costs, extract enormous amounts of profits, right? This is a huge portion of the software industry. A huge portion of the investing landscape is like this too. And it's like, well, why does that work? Like, why is that a thing, right? why would the customers stay on these products, right, if they don't like them? And it usually comes down to some form of switching costs, right? But then, like, what are the switching costs? Like, when you really stare at them, what are they, right? It's like, well, it's really hard to rewrite these jobs and tasks onto a new platform, or to take this code that's written in this language and get it to work in a new thing. It's not just that you can't do it at all. It's just that it needs to be like really good when it's done. It needs to be extremely reliable. If you take an enormous amount of code and you redo it, the best case is you have a new thing that does the same thing as your old thing. And if it doesn't work reliably, like, it's not going to bump up to the top of your list of priorities. And, historically, it's been too hard to automate. And so that's lasted decades. As a business model, it's been very lucrative. But like, is it science fiction to imagine, especially with these, kind of code gen systems, the ability to have computer use agents that can explore the functionality and, just keep iterating on code bases and test things, to imagine that like some subset of these systems that have historically been too hard to automate could go from like really insurmountable switching costs to no switching costs, or very, very, very mild, right? Where you could just redo the thing on the new platform and it works. And like, if your entire business model is relying on like the customers being stuck as a vendor, right, you could be in a pickle pretty quickly.
I'm imagining a boardroom setting. There's 16 people in very nice business wear, and somebody says, "Well, we're in a pickle." I don't think that's the words that they would use. Yeah, I mean, it doesn't seem like a great time to bet on lock-in or switching costs as a strategy.
Yeah, look, I'm obviously you don't want to be naive about it. Like, some of these switching costs are very complicated, right? Like, you look at code, and code, when you're, was often very hardware aware. You're compiling it to specific hardware topologies. But, there's a lot of intermediate representations. With Java, you have the JVM, with compilers, you have LLVM and a bunch of other things on the way to the ultimate topology that you're deploying to, that can make it a little easier to move things. So you have like emulators and a whole class of things, and you can test it in a way that you have maybe built a whole bunch of test cases. You're more familiar with this than anyone, but like in the data world, a lot of that just isn't there. And yet the stuff is just really hardware aware anyway, and performance is important, right? So if you move it to a new system and the performance gets worse, that's not ideal. And also, I would just say there are some of these existing systems are actually better than people think they are in some ways, right? So
yeah, I was going to ask you about that. It's kind of cool to like new technology, but my guess is that there were a bunch of really smart people that built some of the core technologies around the ETL, the original ETL tools 30 plus years ago, and they probably solved some pretty hard problems on the way. Like, if I were sitting here as the founder of one of those companies, what would I say? Like, all this new shit. Like, we figured this out 30 years ago.
Yeah, a lot of these systems are quite robust and mature, and I mean the hardware too, right? Like the mainframe is an I/O supercomputer, right? If you're trying to build a global scale credit card processing system or ATM network or something like that, you would be very hard pressed to find, a system that can run tens of thousands of concurrent transactions against the same refrigerator size machine and have like perfect ACID compliance. And the real reliable transactions, like if you're LinkedIn and you do a status update and then you refresh the page and it's not there yet, and you refresh the page again and now it's there, that's fine. right? But if you're doing like a banking transaction, it's not fine, right? And so and then at the software layer, I mean, you have something like Epic is still running primarily on InterSystems Cache, which was built probably 30 years ago or so.
Those are words that I've never heard before. InterSystems Cache. Is that a mainframe system?
It's a database, a hierarchical database that has been powering Epic, which is one of the key leaders in the electronic medical records and practice management systems. And you've got enormous amounts of concurrent updates happening to patient records, basically in a very robust way at massive scale. It was written in the M/MUMPS programming language, primarily like the core of the system, which is originally developed in the late 60s. And these systems are very resilient. And so if you're going to embark on the project of replatforming something like that, you need the new system to not only be cheaper or something, right? You need it to be as good. You need to be able to handle the workload. You also have this thing, you see this with a lot of the new databases, right? There's constantly people building new databases and trying to convince people to use them. And the idea is, well, we're faster for some use case, right? And it's like, well, okay, but like, how much faster are you? And can we also make our existing system faster by just adding more nodes, right? And also, do you have all the mature database features that take a decade or 15 years to build out? Sometimes the answer is not really. And like now you're asking people to like ETL their data out of their database into your database to do this one thing, right? And you're kind of competing with Moore's Law a little bit, right? Because, okay, maybe it's a little cheaper to use your special purpose database for that workload, but you could also just use your more generic database and add more hardware to it. And maybe today that hardware is slightly more expensive, but the hardware is going to get cheaper, right? So if you're making a multi-year bet, is it really worth bringing in a whole new stack? So I think those are all real world factors. But I do think there's some very vulnerable players who have. There's other types of economic power that a company can have, right? It can be a platform with a lot of stuff built on top of it. It can be, you can have network effects or data moats or whatever. But like, if your only source of defensibility is switching costs and the switching costs go away, it's not a good situation.
Yeah. The conversations that we run into, the breadth of the platform, it's a combination of two things. It's the breadth of the platform where like any modern data stack vendor is not going to go in and replace all of Informatica. This is not going to happen. They're just like, it's a very broad product. And if you can't replace the whole thing, then can you really take the whole budget line? Like, no, that's just very challenging. You also have the other advantage of like, there are still lots of folks who have built entire careers on writing code in these tools. And a lot of them will fight tooth and nail to retain these tools forever. So there's like technical switching costs, I think, are not the only thing. It is a challenging moat to cross.
Yeah, I think you're probably experiencing some of this firsthand, but like what we're seeing when it comes to adopting like data integration oriented GenAI features is that the companies that seem to be doing the best with it are not today the pure play, like let's start from a white sheet of paper GenAI startups, and they're not the legacy declining companies that struggle with doing anything at all. It's this kind of like, medium tier, super high growth company with a fresh product and a team that has a lot of wherewithal to do new things that can infuse. Like Atlan is a good example. I know you know the team there well, right? Like they were already a really good product, right? And it's like, well, if you're going to do the obvious GenAI things for a data catalog, don't you want to do it with like a really good data catalog? And you can kind of like, part of what the system is doing is GenAI is using your product as a tool, right? It knows how to, you can give it access. If you're the vendor, you can give it access to all your unpublished APIs. You can give it deep hooks into the functionality of your product. You can reimagine, like it can do things sometimes that are like much more ambitious than the underlying product itself, that still need the underlying product in order to work. And from the customer perspective, it could be tackling a thing that's like 10 times the value, but you need the distribution, the trust, the fact that the customers are already storing, in their case, like all their metadata with you, and the product functionality in order to get that to work. So I'd say that in the data integration world, database world in general, I'm even seeing this at the application layer. That seems to be the kind of first generation of winners. And I do think if you are seeing a surprisingly large number of incumbents who have like a set of obvious things that they should be doing with GenAI, and they're just not doing it, or they do it and it's terrible, right? And like GenAI doesn't solve the problem of you being a company that doesn't do things. And
one of the things I wanted to make sure to ask you about while I have you, I'm starting to develop a new job title for you as we talk. How do you feel about the data anthropologist? Will you put that on your name card at conferences?
Archaeology, yeah, I like it.
There was this era that I would call the modern data stack era, which maybe lasted, depending on how you measure it, from 2012 to 22 or something like that. And the idea for a little while was that there was so much TAM in this new cloud world that, in fact, all of these different things that had previously, not just Informatica, but like you could just take Informatica and their product catalog and you say every one of these SKUs is actually going to be disaggregated. It's going to be a new company. And so for a little while, I don't know if you've ever seen this like diagram of the Craigslist homepage where you like circle the little parts of the Craigslist homepage. It's like this became Uber, this became DoorDash, etc. And this was like what was happening with Informatica. But then in 22, everyone was like, wait, is there actually enough TAM? And so I'm curious, we're now 3 years beyond that. Do you feel like your thoughts relative to where we were in 2020 versus 2022 versus 2025, now with GenAI here, what's your thought on the TAM of this space?
Yes, the TAM effect is very interesting, right? So when you see in the regular macroeconomic environment, we're used to inflation, right? Call it 2 to 9% inflation or something, depending on the year.
Sure. Normal.
That's not what we're used to in technology, right? In technology, we're used to like relentless price declines. And a lot of what we see is like one generation of, say, application performance monitoring to the next, right? You might see a 90% price decline, but a 10x market size increase. So call it 100x on a per price basis. This is high elasticity of demand. People have been talking a lot about Jevons paradox and AI. That's sort of what they mean by that. Okay, that's a TAM statement. In software, it's interesting because you will frequently have the situation where the companies are much more profitable when that happens because so much of the cost structure is fixed costs that are amortized over more revenue. What you do really care about is not just the TAM size, but as a vendor, you care about the profit pool size. Like it doesn't make sense to invest in a company or spend your time building a company if it's only ever going to make revenue at negative margin and be an investor-enabled service. So, but one thing that you start to need to map out microeconomically is, okay, so let's say, this new set of technologies like drives down a whole bunch of additional costs. Some of these areas have very high elasticity of demand and others have very low. Some cases, like the TAM might completely evaporate, right? Like if you, I know would be a good example, like the corporate logo redesign market. I don't know if I'm not an expert in this market, but like, let's say there's like a fixed amount of companies that want to change their corporate logo every year instead of like a very elastic number, which doesn't seem implausible to me. Like if you cause the price to go from like $15,000 per logo to like 5 cents.
Yeah. If you told me I could do it for 5 cents, I would still keep our logo. I love our logo.
Right. And so you could just see the entire TAM just get vaporized when the price declines. Right. And then there's other things where, a lot of software markets are like this, where the TAM expands massively. I think, some of these infrastructure markets, especially things that touch data, and when you think about the modern data stack, which I think of as like the sort of Fivetran to Snowflake to DBT, maybe a reverse ETL thing at the end market, that was really benefiting from. I was talking about all the contention in the ELT world in the Teradata on-prem environment, right? Once you got into the cloud, you had separation of storage and compute and dynamic elasticity. And so a lot of that was just not an issue, right? You could scale up and scale down. And so you saw a big shift away from the boxes and lines ETL tools back into the warehouse. I'm sure you're already starting to see early versions of this, like, you're going to be able to do a lot more. Like we even have an interactive, like a thing where we can now write in natural language within our, we already store a lot of our portfolio company information and our prospect information in a repository. And like in theory, you could have always written a looker query or whatever to get access to that and to do.
But in practice, people didn't do it.
No one did it, right? It's not like they couldn't have learned how to do it, but they just didn't. And now we can just ask a natural language question and it will generate the query and give us an answer. And it's actually quite good. And you were talking about, sort of opening up new personas, right? Like you had this whole class of self-service tools that were empowering like the Power Excel user type person to do their own data integration or their own dashboarding. But like even, there's another wave of person who has never been unlocked in that way, right? That is still there. And that's like an enormous market.
That you get to like all knowledge workers becomes that
Right.
next wave, right?
For sure. And like, yeah, there's some infrastructure stuff. Like, do you run it on your laptop or are you like calling out to some centralized repository and things like that? But I think a lot of it is just, giving them something that allows them to ask questions that they want to know the answer to and get correct answers. And I'm not saying the correct answer thing lightly. Like I had a situation recently where I needed to do a bunch of cap table analysis, and like I asked one of the language models and it like completely crushed the task, like beautiful charts and pictures, but it was wrong.
Okay.
But you could taste it. Like you could,
and you had to have done that 100 times before so that you could look at it and know it was wrong.
If it had worked, it would have saved me like, at least a half a day worth of associate, and my time sort of iterating. And, to be fair, like the humans who do this kind of thing are not perfect either. But like we're spitting distance from being able to work with structured data in a more reliable way with these tools. And I think my intuition is it's going to unlock a TAM in the data management space unlike anything anyone's ever seen.
All right, well, that's all that time. No, just kidding. I love that line. It's we are so early in this that it's easy for tinkerers to be excited, and yet people that work in go-to-market to be like, yeah, and show me the deal that we landed on this. We just actually had a win come in through Slack yesterday that I got to see. We launched an MCP server for DBT. I don't know.
Makes sense. That's a good idea.
Yeah, like 3 weeks ago or something. And you take all the DBT metadata and you make it accessible via API, which we already had, and then you teach Claude or whatever to interact with it. And a medium-sized financial institution, but like a traditional financial institution, without even us really trying, we don't make a ton of money off this. We don't actually monetize our API right now, which is like the question of like monetization in an AI world is like a very interesting topic. But they fired their data catalog and they say, we're going to the DBT MCP server. I was like, oh, I didn't know that we were there, but hell yeah, let's get on this ride.
One thing you'll see, which it's a little bit like the erosion of switching costs. Like I haven't seen a lot of evidence of this yet. Is like there may be whole product categories that like, even though there's, they're not the legacy products I was talking about where none of the customers like them, like people may love the product, things like that. But no one's ever going to do it that way anymore, right? Their product just doesn't make sense. It's like a really good car service dispatch company in London when Uber shows up, right? It doesn't matter how well run you are, it's just not the way people are going to do it. And and then I think you'll also see for something, DBT has it sort of I think lends itself really well to this world of like wanting to test things, especially when you're dealing with agents that are not 100% sure about their work, but can kind of like operate in a reinforcement style way. As a MCP like interface, I think it's pretty well suited to that. So yeah, that doesn't surprise me. I think we're seeing our catalog companies get a lot of lift from this, like Atlan.
Yep.
And
I'm sure Atlan's metadata coverage is in their APIs far beyond ours. So I have to imagine there's a ton of value there.
Yeah, and like Single Store has been they rolled out a vector similarity search layer that is extremely high performance and allows you to like reattach data after you get results. We're also seeing a pattern, which you may start to come across as well, where instead of doing search and then trying to figure out which data you want to retrieve and chunking it up and stuffing it into the context window before sending it to a model, you instead give your model, which is getting better at tool use, access to your data infrastructure as a tool and let it go and look up stuff in a catalog, and it can do searches and it can get results and then do different searches. So you sort of go through the model on the way to your data infrastructure. And that I think you may see even like database choices. I don't know how much people will care about some of their data infrastructure choices if they're building things with a vibe coding platform, right? Like they may sort of so that could change a lot of the go-to-market activity. But yeah, in structured data, I think one of the reasons why it hasn't manifested so much yet in terms of real world like enterprise sales is that it just doesn't work that well yet, and the customers sometimes care about the thing working.
Yeah. I am very excited about MCP because it is very challenging if the answer that a vendor like us has for a customer is, well, teach all of these users to come into our interface. And then if they come into our interface, then they can do a thing. But if the answer is like, we can build a tool that is exposed inside of the interface that they already use, then that's, I think, very much more compelling. Then you actually think about the TAM from our perspective as, well, how many people have Claude Enterprise or ChatGPT Enterprise or whatever,
and ever ask a question for which, like, calling out to something like DBT, is it a useful ingredient in the answer?
Sure, which I think is like a reasonably high percentage for the enterprise folks. But yeah, I actually don't know the answer to. I don't know if you have any anecdotal data or anything, but like, are these products birthright apps inside of the enterprise yet? Like, what percentage of US knowledge workers have access to the enterprise version of ChatGPT or Claude or whatever?
I mean, I do think you saw a first wave of large companies think that they needed to build their own kind of janky, like front end to a back end API that was a frontier model because of compliance reasons or something like that, because there was like a 6-month window before you could get like a industrial grade compliant version of things like ChatGPT Enterprise. But the adoption, I think, is extraordinarily fast.
Yeah. And it's all like ELA based or seat based or something, right? Like
they do it seat based today.
Yeah.
But I imagine as it scales up into really large companies, you'll start to see bulk discounts, and there's definitely, it makes the product better when more people have access to it, right? Because you can do things like share custom GPTs and things like that. And the IT team, I think the goal in a lot of these cases is to get these technologies into the hands of the people who are doing the work, so you can see what they're going to do with it rather than try to like guess that ahead of time. And then the role of centralized IT is to harden things, but harden things in these cases may be giving them access to the GPT MCP server and like actually building that connection. And then I think the vendors like the Anthropic and OpenAIs of the world, when you have something like deep research, right? Today, it just basically does web search, but like it's obviously going to do file search too, right? And then also, don't you want it to have access to your data? Like, wouldn't that be useful? Like, how many questions do you ask within a company where you don't also want it to look at your data, right?
Yeah. I have to imagine data providers like PitchBook and other, that becomes like a highly monetizable data set in this context,
right?
Too.
You should also be able to subscribe somehow through your API keys or whatever to your data providers that you subscribe to. That's obviously a useful ingredient in the answer to the question. Like, if a model is going to run for 30 minutes, iterating on the stuff that it learns and then doing more research to give you like a really sophisticated report, it's kind of a toy if it can't access your actual data.
Oh, this has been a lot of fun. I'm looking forward to the next episode of this where we do the whole thing again for BI. No, I've learned a lot, and it's not often that I get to spend an hour going into 50 years of history in the data industry. So thank you so much for joining.
Yeah, thanks for having me. Really enjoyed it.
The Analytics Engineering Podcast is sponsored by DBT Labs. I'm your host, Tristan Handy. Email us at podcast@dbtlabs.com with comments and guest suggestions. Our producers are Jeff Fox and Dan Poppy. If you enjoyed the show, drop us a review or share with a friend. Thanks for listening.